Okay, so for this next part, I'm only going to do a couple of these and let you do the rest. So for part C, it says, and this is part C from the last problem, at x equals 1, the graph is, and I'm supposed to see if it's increasing or decreasing, if there's a possible min and max, and then concave up, concave down, whether it's an inflection. So x equals 1. For this original equation, that we decided was a possible inflection point because the concavity changed from negative at beforehand and then positive after. So let's see. So we decided it's a possible inflection point, and now we're supposed to decide if it's increasing, decreasing, or it's a possible min and max. Okay, to me that definitely says decreasing, so we will do that part. Okay, so I'll skip D because it's the same kind of idea. And let's do H. So g of x has a minimum at x equals what? Okay, so let's go back up. This function has a minimum at x equals 3. And we know that for a couple of reasons, and one of them is because the derivative has an x-intercept at 3 that goes from negative to positive. So that's one way we knew it was a minimum. We could also look at our table and say exactly the same thing, actually. Okay, so that was 3. Because the graph of the derivative has an x-intercept, and the graph goes from negative to positive. Okay, so this next little bit, when reading the graph of the derivative, some things to keep in mind are the y value of the derivative is the slope of the original at that point. A positive number, that would mean the same thing as the derivative is greater than 0, means the original graph is increasing. A negative number means the original graph is decreasing. The slope of the derivative is the second derivative. So actually, I probably should have written that second derivative. Or concavity, either works. So a positive number means the original graph is concave up. A negative number means concave down. Okay, we will pause here then.